Joey Gonzalez, thanks for chatting with me at Laudecast. You're a professor at Berkeley. You did a postdoc at Berkeley, same time that I was finishing my PhD there. Mm-hmm. You've done some startup work and multiple startups. GraphLab, and more recently, Letta,
Run LLM.
Yep. You're intersectional. You're passionate about technology research and transfer of that into startups.
Yeah, I work on the kind of intersection of AI systems. Actually, this conference is kind of a neat place, bringing agentic systems and AI and the ACM and the systems community together. In fact, I'm the general chair for the upcoming MLSys too, which is kind of in the same space of AI systems as
Dave asked me what's the difference between this and MLSys.
MLSys conference grew actually over a 10-year period. Things were much slower back then, where systems, in fact, you were involved in this early effort, where systems and AI people started to come together. And it's a neat story how systems and AI, separate fields, as they came together, this idea of scaling became a central theme of that mission. My thesis work and Matei and others in that time period were, how do we take machine learning and not just make the models better, but bigger? How do we access more data? And would scale unlock new capabilities? And it turns out scale did play a pretty big role in unlocking new capabilities. And so that kind of fusion of fields of different minds coming together, systems people, engineering mindsets, data mindsets, and statistical modeling mindsets that made AI systems and really made the modern era of AI.
I mean, I guess data munging and things like what we do at Databricks with Spark and the customers who are getting, like, there was a shift of investment at enterprise level, but then one of the big key insights for pre-training that led to sort of a large enough scale for the emergence of general knowledge and intelligence was scraping the internet. And so that's like a little bit antithetical to the need for these data systems that are like organizing and curating and making your, bronze, silver, gold level data. How do you see the data paradigm playing into the buildup?
The role of data, the kind of journey of data, didn't start with OpenAI. It actually went much further back. There's things like ImageNet. We started to collect large data sets. There's a lot of work in the system side to not just scale the data, but the computation and how they work together. Projects like Spark, projects like my thesis, GraphLab long ago, we're looking at ways of bringing the data and computational capabilities together in a way that we could innovate in the models and algorithms and techniques. That work led on to projects like PyTorch, TensorFlow, that pushed those systems further, accelerated our ability to develop new models, to scale those models. And I think maybe in the kind of 2017 to 2019 timeframe, people started to imagine, like, if I could take really large vision data sets, I could build bigger and bigger and more capable, more general models. And the same happened with language. And I actually remember like 2018 or so, we had been working on this. OpenAI was also working on this idea that as we make the models bigger, somehow magically they learn faster in time, because we can leverage more parallelism to compute more effectively, but also the more data actually allowed the model to just learn quicker. And these these scaling laws came out of that work, and that gave us the confidence to keep pushing scale further and further and open up these new, essentially more general capabilities.
Mm-hmm. How do you see what's playing out now in the kind of landscape from open research and closed research going? And are you worried, or do you think everything's copacetic?
This is a hot topic, a concerning topic for me. Where is open research going? Where is closed research going? It's crazy that 5-6 years ago, OpenAI was an open thing, and like the open meant something. We're in a really scary and exciting time. So research is going much faster. A single grad student can do way more. And so there's a lot of opportunity for us to innovate, to not just climb the hills that we have, but to invent new hills to climb, which is awesome. But at the same time, the great students that are doing really cool stuff are getting plucked out of the PhD programs and pulled into these labs, offered comical amounts of money that I can't compete with as a professor. And I think there's a real risk.
We're talking like multiple $1 million per year in equity.
Millions of dollars per year, yeah. So faculty don't get paid anything close to that. But grad students in their first or second year have some amazing result, really great potential. And I think industry is getting better and better. Going, that is an amazing student. They would make an amazing part of our team. And they're not wrong. And we're seeing this talent being pulled into a smaller and smaller group of organizations. And I think there's a real risk that the next generation of innovators, of thinkers, won't exist because either they got pulled out of grad school or they won't even go into CS or into AI research because these frontier labs have been so successful at kind of convincing the world that we don't need that. And I think there's so much opportunity for graduate students, for computer scientists to shape what AI is for all of us. And it would be a shame if that was just pulled into a small set of organizations.
Yeah, I've often thought about the risk in terms of PhDs who would have likely stayed in academia and created the next generation of faculty that would mentor the subsequent generation. There was this recursive dynamic in academia because the core program is advisor-advisee. So you have a close partnership, and the gist or the main reason to do it is to train up the next generation. And it turns out that the best way to train them to be as luminary as the current generation is to work on research. But it's subtle at the top universities, but it's still the main thing is that you're in a mentorship program. Like you're actually learning a vocation, which is to be one of the world's best researchers. And the best way to do it is to spend 5 years glued at the hip to one of the world's best researchers. And the big labs they don't have that mechanism. So I've thought of that as the main risk because they break this recursive loop that we've had for millennia. But you're also pointing out another risk vector, which is the discouragement of the generation one below that coming into undergrad and halfway through the undergrad dropping out of CS and not even getting to the PhD program or even through computer science as an undergrad.
I want to emphasize, this is a very important point. We got to where we are today, not just because of great academic research, but because of that collaboration between industry, between academia, OpenAI being open, Google Research being open. It inspired the next generation of graduate students, maybe the next generation of undergrads to go into this field. That excitement, that energy is critical to the future of our field. We can't just hand that off to AI. And I'm very worried that we're quickly moving to a situation where that excitement is lost, where it gets concentrated in a small set of very powerful companies, and the technology, the innovation, but even the people behind it aren't there to make the next big leaps that we need to make.
So what are you doing about it?
Yeah, so what am I doing about it? So I'm still in academia. I haven't left my job. I'm trying
Well, that's one thing.
Yeah, it's one thing. I'm trying to encourage graduate students to take that risk, to bet on themselves, to be able to be the pioneers that will take us where we need to go next. Part of that is picking research agendas that aren't just climbing the hill that the billions of dollars are racing to the top of, but finding new hills, anticipating where the field's going. I think for my career, if I look back at each point in my career, I basically assumed I would lose at the thing everyone was doing. So when I started my PhD, everyone's building models. I go, you know what? I can't build models as well as them, but maybe I can scale them. So once they have good models, I'll scale them. As I started as faculty, I was like, you know what? I can't scale models as well as Google, as Facebook, Meta at that point, but maybe I can serve them. Because once they build really big models, the next problem will be, how do we use those models? And so I went to inference. And now what comes next? And for me, a lot of that is, I think our AI is going to get to be amazing. We have these conferences, we have all this innovation going on, and hopefully we have grad students continue to work on it. I think maybe what comes next is the challenges that AI will create for the world around it. So one of those challenges is the systems we build need to be able to handle this new workforce of very capable agents that can do far more, far faster than a human. And so I think there's a real opportunity to rethink the software systems we built that were designed to serve humans to now serve AI more efficiently, more effectively.
What's a specific example?
So a great example, take a database. We're at an ACM conference. A database today is designed to take queries from a human or maybe from a very simple dashboard. But you could ask an agent, hey, solve my business problem, and it can ask thousands of queries per agent, and then have thousands of agents working against that database. They'll ask harder queries, more complex queries. But the database doesn't have to answer those queries. It can say no. And this is a new era for how we build systems, that the system doesn't have to be as forgiving, as friendly as it would be to a human. It can say, here are 1,000 other queries that I can process more efficiently. Can you rank them and choose your favorite? This is an opportunity to rethink the abstractions, the interfaces we built to serve this next set of workloads, this next set of users. And I think that'll be critical to making our world more effective and more adapt to what AI can do and what it can offer.
And your sense is that the big closed AI labs aren't focused on this right now. This is sort of your call for where the puck's going.
That's right. So I think they're focused on, the big labs should be and need to be focused on really advancing what their AIs can do. And in many ways, that's adapting to the world as it is today. But I think we, as research, have an opportunity to think what the world could be tomorrow to make that more effective. And I think maybe the more important part of that is to figure out our place in that world. And so as we scale systems, as we scale AI, the remaining thing that doesn't scale is us. And I think our ability to communicate, to command these new forces is something we can be studying today in academia. Much like maybe, you have a chief of staff that helps you work with your army of capable people. What would that look like as we work with our armies of agents? How do we articulate our preferences more effectively? We have research on how do I learn from my rewards? I'm very happy with what you said. Do that more. How do I communicate that more effectively to a team of agents that might support me someday?
I'm curious, you said that you're advocating to your students about the advantages of staying. And one of them is that we can look a few years out. Often we think of tenure as a protective type of mechanism that lets us take maybe even decades-long research bets. That feels maybe compressed now in the time of AI, where we're talking about months or a year instead of weeks or month. And I'm curious, how well is that resonating? Are there other edges or advantages that resonate with a young generation of PhDs that would be compelling for them to stay in? Because it's getting to a point where they have to be willing to say no to many millions of dollars. And one argument I frequently find myself using is the power and the value and the impact of what we're working with, what you're studying, is so great that dollars is the wrong unit right now. It's like society level change that is like more valuable, but kind of harder to get your brain around. For anybody that grew up that's in their 20s now, the dollar meant a different thing than I argue it means right now. And so kind of trying to see past the dollars and see like the more profound root cause of the impact, which dollars is a measure of, and that the advantages we have in academia can be on more exploratory instead of exploitative research, or maybe a little slightly farther out research that can be one or two steps ahead. Is that resonating with them?
Yeah, absolutely. So I'm going to broaden the scope of what PhD students are starting to think about. It used to be papers was the goal, and now in the past 5 years, thanks to work from people like you, we've moved to what is my impact in software and systems. I think when I look at the next generation of grad students, one thing I see more excitement around is being involved in policy and shaping what that world looks like that they will inherit, and how they will adapt the technology and the ideas around it to influence that world. Many grad students coming to, maybe I'll build a company around it. And remarkably, a company is a way to shape what that world looks like. I think, again, taking that bet to push beyond where research is going, to ask the questions about what would I like it to look like and how can I move the industry and the humanity as a whole, is something that a graduate student has the time, the space to do. And that's kind of priceless.
Yeah, that's really interesting. I hadn't thought about this before, but the intuitions that I honed working in like Patterson labs that we were working in together around impact and other vectors of impact besides publication, which was this time-tested one, finding that startups was the next big route. And now I've spent a lot more time thinking, when we talk about societal level impact and species level swings, about this other idea of just influence and soft power. Why is Elon Musk so powerful? Like, yes, he's the world's richest person, but it has to do with the relationships that that people like this foster, the political influence one can achieve. And so it hadn't dawned on me that PhD students might find the next chapter beyond just how do we have impact through product, which is a company out of your research, to take the next step to like how do we have influence and soft power in the world around us, a thing which will become much more important as societal level change rolls out for their children or all of our children.
Yeah, absolutely. And I think this is something that, as academics, we don't typically think about. And it's something that,
No, far away from it.
We have to learn about. I had to get into Twitter recently, one form of communicating. But I think the idea that we might be more involved in policy, that we have to be able to communicate our story as a researcher, but also as a human as part of this process, so that the broader world has a sense to understand where we want things to go, where it can go. So it is not, driven by our parents' generation.
Yeah, great. Cool. Okay, we'll call it there. Thanks so much.